Hi, in this video, we're going to discuss solving trigonometric equations for the IB Analysis and Approaches non-calculator paper. The first question says, show that sine 2x plus cos 2x minus 1 is equal to 2 sine x times cos x minus sine x. It's really up to you how you solve this. You can choose to start from the right-hand side and show that expansion takes you to the left-hand side, or you can start from the left-hand side and then show that expression simplifies to the right-hand side. Okay, so the left-hand side expression says sine 2x plus cos 2x minus 1 is, in order to rewrite this, we're going to have to use some double angle identities. Double angle because you can see that you have double angles here. Right? They're multiplied by 2, hence double angles. Right. Okay. So for you to know which variation of the double angle identities to use, it might be helpful for you to start off by expanding what you want the end result to look like, right? So if you multiply 2 sine x, you get 2 sine x cos x, and then minus 2 sine squared x, right? So you can see that whatever double angle identities you end up using, they at least need to look like that expansion that we just did. So the identities that we're going to use are, for sine 2x, there's only one option. That double angle identity is 2 times sine x times cos x. For cos 2x, you do have a couple of options to pick from. We're going to use 1 minus 2 sine squared x. So yeah, in the place of sine 2x, we're going to write 2 sine x cos x. Already you can see it kind of looks like the first term in the expanded expression. Okay, in the place of cos 2x, we're going to use, sorry, it should be a plus. 1 minus 2 sine squared. And then there was already a minus 1 in the expression. There are some like terms, like you can see there are two constants there that we can add together. So positive 1 minus 1, positive 1 minus 1. That gives you 0. And then you remain with 2 sine x cos x minus 2 sine squared x. And that, if you factor out 2 sine x, will look just like the right-hand side does. So we would multiply 2 sine x with cos x to get the first term back, and we would multiply 2 sine x with sine x to get the second term back. And that's it. That is the right-hand side. And that's how you show part A. Part B says, hence or otherwise, solve sine 2x plus cos 2x minus 1 plus cos x minus sine x equal to 0 for any values of x that are between 0 and 2 pi. Okay, when it says hence or otherwise, it's basically saying now that you know that you can rewrite this expression with this expression, right? You can swap those two expressions or write them and substitute them for each other. Then now solve this equation. So initially the equation says sine 2x plus cos 2x minus 1 plus cos x minus sine x equal to 0. So this is the expression we can substitute for. We can substitute 2 sine x times cos x minus sine x for that. And then the second term will still be cos x minus sine x. So now we have an expression with two terms. This is our first term, this is our second term. And that's how I'm going to factorize them, treating those two like they're two terms. Right. Okay. So to factorize this, you recognize that the two terms I just highlighted have cos x sine x in common. Cos x minus sine x. So that forms a bracket of its own. And then in the other bracket, we put what we would multiply it by to get the first term back. So we would multiply it by 2 sine x. And to get this term back, we would multiply it by 1. Okay, when you have a product of two brackets, so you have two brackets multiplying each other, how could you get 0? Well, it's either the first bracket would give you 0, and then now you would be multiplying by 0, so then that would give you 0. Or the second bracket could give you 0, and you would be multiplying the first bracket by 0, and then that would give you 0. So let's solve those two equations. First, I'm going to add sine x to both sides. So it's now cos x is equal to sine x. Then I'm going to divide both sides by cos x because we know that tan is equal to sine over cos. So that's what we're taking advantage of right now. So that would be 1 is equal to sine x over cos x. Then that means we are looking for when tan x gives you 1. Right. It's really up to you how you handle this in a non-calculator paper. Um, you can choose to remember which values of x give you 1, or you can use some special triangles to work it out. So the special triangle we're going to be working with for this part is an isosceles triangle, right? And it should be right angled. Okay, so it looks like this. So that's the right angle. Since that's 90 degrees, the base angles will have to share the remaining 90. So that's 45, and that's also 45, right? And then we say it's isosceles, so the two sides are equal to each other. And then to work out the hypotenuse, we can just use Pythagoras' theorem to be square root of 1 squared plus 1 squared. So basically, square root of 2. Okay, so how could we get 1? You could get 1 by doing opposite over adjacent, right? Tan is opposite over adjacent, so that's how you could get 1 if you used 45 degrees. So that's it. 45 degrees is the angle that gives you 1, right? But we're working in radians, so you just need to remember that 45 degrees is pi over 4. Yeah, but this angle shows you that tan 45 is 1. You can also use that triangle to figure out what sine 45 is. That could tell you that's 1 over root 2. And then cos 45 is also 1 over root 2, adjacent over hypotenuse, right? So that's a triangle you can use to figure out all your 90-degree, all your 45-degree values. Anyway, from that triangle, we figured that x is equal to um, pi over 4. Then there's another thing we need to consider. There could be other values within the range that you were given. You were told to find all the values between 0 and 2 pi. So there could be other values that give you 1 when you substitute them into 10. So in order to figure those out, we're going to use a cos diagram. All your trig ratios are positive in the first quadrant, and this is where you do all the angles that are between 0 and 90 degrees, right? So that's where 45 would go. We found out in this quadrant, x is equal to 45, right, which is pi over 4. Then in the second quadrant, only sine would be positive. We don't need to think about that quadrant right now because we're looking for quadrants where tan is positive. But if you were working in this quadrant, you would get values between 90 degrees and 180 degrees, right? Between 0 and pi. And then to work those values out, you would just do 180 minus the angle that you got in the first quadrant, or since we're working in radians, it would be pi minus pi over 4, right? But we're not in that quadrant right now. We're in the third quadrant where tan is positive because we're working with tan. So in this quadrant, you get the values that are between 180 and 270 degrees. And so here you do pi plus x. So we're going to do pi plus pi over 4. And that's how we know that the value of tan in this quadrant is 5 pi over 4. So that's our second answer, 5 pi over 4. Great. You can also work in the fourth quadrant. We don't need that right now, but in that quadrant, you get the values that are between 270 and 360 degrees, 2 pi, right? That is, you do 2 pi minus x, minus whatever value you got in the second quadrant, in the first quadrant. And in this quadrant, cos is the positive one. So that's the cast diagram. Anyway, let's solve the second equation. We got all the values that we needed between 0 and 2 pi. We could only work in the first quadrant and in the third quadrant. The others didn't allow for tan to be positive. Okay. Let's solve the second equation. Subtract 1 from both sides and then divide by 2. That's negative 1 over 2. That also introduces another special triangle. You could really memorize the final result, but just in case you forget what the final result looks like, or you forget what the angles are, it's really okay. You can expect these things to happen in an exam because there's a lot of pressure going on. So because of that, I'll just explain to you how you can create the triangle from scratch, but you can just remember the final result. That would be the most ideal scenario. Okay, so you start off with an equilateral triangle. So you create an equilateral triangle that has all the side, the units should be 2. The units should be 2. Okay, so it would look like this. All the angles are equal because it's equilateral, and all the sides are equal to 2. And then you half that equilateral triangle. That will give you a right angle triangle. Still, this is 2 and this is 1. And then you could use Pythagoras' theorem to work out that this is square root of 3. And then this is still 60 degrees. This is where we cut it in half. That top is now 30 degrees. Right. So now this triangle can help you figure out sine 60, cos 60, tan 60, and cos 30 and sine 30 and tan 30. That's what this is useful for. So we're working with sine, which means we're interested in opposite over hypotenuse. So that means the opposite needs to be 1 and the hypotenuse needs to be 2, right? That's 30 degrees. And we know that 30 degrees is equal to pi over 6. So that's the first value that we're getting from that question, part of the question, x is equal to pi over 6. We need to use the cast diagram to find out if there are any other values between 0 and 2 pi that can give you negative half, right? Actually, I don't think pi over 6 is one of the answers. Let's track back on that. Done? Okay, let's do the cast diagram. You see why. We have negative half, not half. So here, sign would be positive, but you can see from this sign, we're not interested in the quadrants where sign is positive. So we're not interested in this quadrant. We're not here. We're also not here because this is where sign is positive, and so we're not in that quadrant, but we're in the third quadrant because sign is negative there. So we're going to do pi plus pi over 6. That would be one of the answers. And then also in the last quadrant where cos is the only positive one, sign is negative there. So we're going to do 2 pi minus pi over 6, which is 11 pi over 6. Great. Great. So that's pi over 7 pi over 6 and 11 pi over 6. Okay. So those are all the solutions. If we're going to write them in order, then we have 45 degrees, and then we have 210 degrees, and 225 degrees, and 330 degrees. Those are all the solutions to this question. Right. You have to list all 4 solutions in order to get your full marks from the previous question. Next question. It is given that cosec theta is equal to 3 over 2, where theta is between pi over 2, 3 pi, and 3 pi over 2. Find the exact value of cot theta. Okay, so you have to remember that cosec theta is the reciprocal of sine theta. What does that mean? Sine theta would normally be opposite over hypotenuse. So cosec theta is going to be hypotenuse over opposite. You swap the denominator and the numerator, right? And then cot theta is the reciprocal of tan theta. So instead of doing opposite over adjacent, we're going to do adjacent over opposite, right? Sorry. And instead of adjacent being in the denominator, we have it in the numerator. Great. So let's see what that triangle looks like. They said cosec theta, right, which is hypotenuse over opposite is equal to 3 over 2. So if we draw that on a triangle, the hypotenuse is 3, the opposite, so I'm going to put theta here. If you put theta at the top, you know where the opposite would be. It would be here, right? But since I put theta on the side, the opposite is going to be up here. Okay. Then we can work out what that missing side is. That's going to be square root of 3 squared minus 2 squared. We're using Pythagoras' theorem here. So that's square root of 5. That missing side is square root of 5. So now we can work out cot theta. That's going to be adjacent over opposite. Right. That's it. That's the answer. Find the least positive value of x for which cos x over 2 plus pi over 3 is equal to 1 over square root 2. Again, remember your special triangles. You really can just memorize the final results. This one, we're working with the one that has square root 2 involved. So you can see, once again, we're working with 45 degrees, which is pi over 4. So that's, why did I say 45 degrees? Adjacent. Oh, we're working with cos. My bad. Let's fix that. Adjacent over hypotenuse. That's 45 degrees. Okay. So let's write that out in the equation. We want cos of x over 2 plus pi over 3 to equal 1 over root 2. And in order for that to happen, x over 2 plus pi over 3 needs to be equal to 45 degrees. Right? We can solve this like a normal equation. Subtract pi over 3 from both sides, and you need to work that out like you would any other fraction. Pi over 4 minus pi over 3. Multiply the first fraction by 3, you get 3 pi over 12. Multiply the second fraction by 4, you get 4 pi over 12, 4 over 4. Yeah. So that's going to give you negative pi over 12. And then you multiply both sides by 2, and you get x is equal to negative pi over 6. But note, the question said the least possible positive value. That's negative. So we're going to need to use the cos diagram to figure out what other values can give you a positive answer. Let's see. So we were in the first quadrant, and that gave us, that was pi over 4. We need to go to the last quadrant because cos is positive there. We're working with cos, right? So that would be 2 pi minus pi over 4. That's the only other value we could work with because this is positive. Right, let's see what that is. That's 7 pi over 4. Okay, so we're going to solve the equation again, but this time with 7 pi over 4. Let's see. So so this one is out, so the other way, or x over 2 plus pi over 3 can equal 7 pi over 4. Again, we're using that subtraction. Seven pi over 4 minus pi over 3. That's going to be 21 over 12. 21 pi over 12 minus 4 pi over 12. Great, that's 17 pi over 12. Okay, that's getting tricky to write. Hold on. 17 pi over 12. Great. Then multiply both sides by 2. That gives you 17 pi over 6. That's the positive value. That's the correct answer. Okay, consider the functions f of x is equal to square root 3 sine x plus cos x, where x is between 0 and pi. Gx is equal to 2x, and x is a real number for that. Find the composite function. So we're being asked to find f of g of x, which means we need to put g of x in the place of x in the function f. So anywhere you see x, you need to put 2x. So now it would say square root 3 sine 2x plus cos 2x. And that's it. We can just stop there. Or you can simplify it if you want to. Don't think that's necessary. So let's go to the next part. Solve the equation that equates what you just found to 2 cos 2x. And this time we're stopping from 0 to pi. So you don't need to go any further. So this is 0, that's pi over 2, that's pi. You don't need to even consider the third and fourth quadrant. Don't go any further than pi. So we're only going to consider solutions that fit in the first and second quadrant. Okay, so that's going to be square root 3 sine 2x plus cos 2x is equal to 2 cos 2x. Those are like terms. These two are like terms. So just picture like you subtract, when we subtract cos 2x from both sides, picture like you're doing 2a minus a. What you get? You get a. So 2 cos 2x minus cos 2x is cos 2x. And here we remain with square root 3 sine 2x. Okay, now we can divide both sides by, this is a bit annoying, but we can divide both sides by sine 2x. Then you have cos 2x over sine 2x. And that is the reciprocal of tan, right? We said earlier, tan is sine over cos. So that means cot is cos over sine, right? So I'm just going to find the reciprocal of both sides. The reciprocal of this side is 1 square root 3, and then the reciprocal of cos over sine is tan. Great. Okay, what value would give 1 over root 3 when substituted into tan, right? That's what we're trying to figure out. We need to use a special triangle, and like I said before, you can just remember the end product of it, right? We're using the 60-30 triangle. So remember, 60 stayed the same and 30 was halved. Um, then this stayed 2, that stayed 1, and this was square root 3. So you can just remember that. But remember, it comes from an equilateral triangle with all the side lengths being 2, and then you halve that to get a right angle triangle. This is the result. Great. So how do you get opposite over adjacent giving you 1 over root 3? Oh, opposite over adjacent. Yeah, it's 30 degrees. The 30-degree angle does that. So tan 30 is equal to 1 over root 3, which means we're going to equate 2x to 30 degrees. We're working in radians. 30 degrees is pi over 6. Okay, divide both sides by 2 or multiply both sides by half and you get x is equal to pi over 12. The other quadrant where tan would be positive is the third quadrant, which we said we're not considering at all. So there's only one answer to this question, pi over 12. If they said 2 pi here, that's when we would consider 13 pi over 12 as a solution, but they didn't. So we're sticking to pi over 12 as the only solution. Okay. Question 10 says the function f is defined by f of x is equal to cos squared x minus 3 sine squared x. Find the roots of the equation between 0 and pi, right? Once again, that tells you that you're not going to look for any solutions in the third quadrant or the fourth quadrant. You're only focused on the first quadrant and the second quadrant. So let's see what that's going to look like. Cos squared cos squared x minus 3 sine squared x. We can use another identity to rewrite cos squared x. It's really up to you which one you use. There are quite a lot of variations, but I'm just going to use the Pythagorean one, the one that said cos squared plus sine squared is equal to 1. So when you subtract sine squared from both sides, you know that cos squared is equal to 1 minus sine squared, right? So that's 1 minus sine squared x minus 3 sine squared x. And that should be equal to 0. Okay, so when we simplified that, we get 1 minus 4 sine squared. They're like terms, so they add each other. Is equal to 0. And then I'm going to add 4 sine squared on both sides. Then divide both sides by 4. Then we're going to find the root of 1 over 4, which would be positive or negative 1 over 2. Just remember, root of 1 over 4 is equal to the root of 1 over the root of 4, which is 1 over 2, right? But it could be positive or negative. Okay. Yeah, let's just move that along. It may cause problems for me. Okay, so sine x is equal to positive or negative half. Like I said already, we have to be careful about which quadrant we're in. So we can't consider the bottom quadrants, which means we're not going to consider the case where it gives us negative half. We're only considering the cases where it gives you positive half, which is the top two, right? Where sine is positive. Sine is positive in the top two quadrants. So we actually don't need to consider this negative option, right? Just the positive one. Okay, so when is sine positive? Half. Yes, we can use the triangle that I was talking about earlier. You really don't have to memorize the triangle. You could memorize the values, but it's up to you. Um, there we go. This is 1, this is 2. That's all we need really right now because we want half. But yeah, you can see once again, opposite over hypotenuse is happening with 30 degrees, pi over 6. So sine pi over 6 gives you half. So x could be pi over 6. Or in the other quadrant, it's pi minus pi over 6. So that would be 5 pi over 6. Those are the two values that we're considering as roots for part A because of the domain that you've been asked to use. Right. I'm just saying we could have also used 7 pi over 6 and I think it's 11 pi over 6 if the domain was stopping at 2 pi. Anyway, part B says find the derivative of cos squared x minus 3 sine squared x. So let's do that. We're going to have to use the chain rule because cos squared x actually looks like this. It's a power function with a function on the inside. So the power rule says, this is now a side topic, but eventually we're going to have to solve a trigonometric equation, which is why I'm not skipping this. But yeah, we can look further into derivatives in another video. It's not the main point of this video, right? So that's going to be 2 cos x times the derivative of cos x, which is negative sine. Then we're going to keep negative 3 as it is, and then 2 sine x times the derivative of sine x, which is cos x. That's the derivative, and that's equal to negative 2 cos x sine x minus 6 cos x sine x. Okay, so that's the derivative. I can add them together. They are like terms, so it's going to be negative 8. I think the more natural way to look at it is to have sine written first, but really, multiplication is commutative, so you can write it anyhow. Then the next part says find the coordinates of the points on the graph of y where the derivative is equal to 0. Let's look at it this way. We need to solve this equal to 0. That's the second part of the question. We need f prime x, which is actually negative 8 times sine x cos x to equal 0. There is also another way to write this. If you consider the double angle identity from before, the one that said, if you consider here, just remember that sine 2x is equal to 2 times sine x cos x, right? Then we can use that to rewrite the derivative one more time, and that would be negative 4 times sine 2x. I think that's a way simpler way to look at it, and that's equal to 0. So we're looking for parts where sine, when you divide both sides by 4, negative 4, you get sine 2x is equal to 0. So we want what angle gives 0 when you're dealing with sine. So the way I like to remember the 0 and 90-degree angles is like this. So let's just write all the trig ratios, cos and tan, and then 0 and 90 degrees. Sine 0 is 0, right? Sine 90 is 1. So cos 0 is 1 and sine 90 is 0 because they swap like that. And then since tan is sine divided by cos, 0 divided by 1 is 0, and 1 divided by 0 is undefined. So I like to use this little table to remember the 0 and 90 degrees angles. You can just memorize them, keep them in your head. You don't need a table. Good for you. But there's no triangle for this one. So you probably just need to use a table like this. Okay, so how can we get sine something to give you 0? It's if 2x is equal to 0. 2x is equal to 0. Right. 2x can be equal to 0, and then that means x is equal to 0. Yay. There is another angle that does give you 0 when you're dealing with sine. I think it's also 2 pi. Let's see how they wrote, but we're not in those quadrants at all. Let's see if there's another way to get 0 with this. To get, 0 with sine. 2x can also be equal to, I think pi does work. I think 180 is also a 0-degree angle for pi. It is. It is. Also, another one that you can't find on anything unless you memorize it is 180 degrees. Think sine 180 is 0. That you have to maybe kind of remember what the graph of sine looks like. That might help you because it looks like this. It's 0 here, and then it goes up to 1, and then it comes back to 0 at 180, right? That's kind of how it works. And then it gives you 1 here at 90, right? So it obviously goes back to 0, then it goes to -1 at 270, and then it comes back to 0 at 360, right? So 180 is definitely a 0 for sine. A lot to remember there when you're not using a calculator, but in any case. So 2x can also be equal to 180 degrees, which is pi. And then if you divide both sides by 2, x could be pi over 2, which is still in the range that we're working with. It's still between 0 and pi. So I think those are the two answers that you can get. Let's see. Is there an equal sign on that pi? Yes, there is. Okay. Or, again, another or. 2x can also be equal to 2 pi. And then if you divide by 2, it gives you pi. Yeah, that fits as well. So 0, pi, and pi over 2 can work. That's mainly because we're working with 2x. We're working with a double angle, not working with just x. So just keep that in mind. All of that. Anyway, all the answers that we can get are 0, pi over 2, and pi. Yay. Okay. Okay. Question, I can't remember what question this is. This is probably the last question though. Yes, it is the last question. Solve cos 2x is equal to sine x, where x is between pi and negative pi. Okay, cos 2x is equal to sine x. Now we're going to use that same double angle identity from before, where we said cos 2x can be written as 1 minus 2 sine squared x, and that's equal to sine x. Then I'm going to move everything over to the same side. There's a quadratic effect with the power of 2 that's happening here. So I'm going to move everything to the same side. It'll be 2 sine squared x plus sine x minus 1. And then because we don't want to, I just want to point out how this is a quadratic. Let's just rewrite sine x as u, right? So now you can clearly see that it's a quadratic equation. It looks like 2u squared plus u minus 1. You can factorize this, which is the most useful way to solve quadratic equations when you're not using a calculator. But this has a coefficient here, so it might not be the fastest anymore. It would just be as long as working with the quadratic formula. So I'm going to use the quadratic formula. -1 plus or minus square root of b squared, which is 1 squared, minus 4 times a, which is 2, times c, which is 1, -1. Okay, divided by 2 times a, which is 2 times 2. So that gives me -1 plus or minus the square root of 9 over 4. See, way better, but not so bad. Even if you don't have a calculator, we know that the square root of 9 is 3. So the two solutions you could have, you could be -1 plus 3 over 4, which would be half, or you could be -1 minus 3 over 4, which is -1. So we're saying u standing in for sine, right? Yeah. So sine x could be half. And I think over and over again we've emphasized which triangle can help you solve this. It's the 60, 30, 90 triangle, right? 60, 30, 90. And we said it's 30 degrees, sine 30. That gives you half. We're supposed to be between negative pi and pi. Okay, so that gives you x is equal to pi over 6 and 5 pi over 6. Again, Cut's diagram helps you figure out which quadrants, you're working in. We're in the quadrant where sine is positive, so that's why I'm taking pi over 6 as an answer. And we're also in the quadrant where sine is positive, so second quadrant, pi minus pi over 6 is 5 pi over 6, right? That's how we know those answers will work, and we're stopping at pi. So this is 0, pi, right? We're stopping at pi. We're not going to look at the third and fourth quadrants. Okay, sine is odd, so even I don't, you won't get the same answer for half using -30, for example. You don't, for cos is even, so you would need to also include negative pi over 6 and negative 5 pi over 6 in these options for cos. But yeah, since sine is odd, we're only going to take the positive values that it gives us. Okay, next slide. Sine x is equal to -1. Remember the little diagram I made for the graph of sine just now, where I did this, right? And this was 2 pi, and this was pi, and that was 0. Well, this is where you get -1, right? At 3 pi over 2. At 270, that's where you get -1. But we're not considering those. It's not in the range we were given. It's above pi, so we're not going to consider that as an option. Let's see, however, if you continue the graph of sine to the other side, which is the negative side, you would see, here we go, let me continue it. There we go. Here, you get -1 again, and then you go back up. Sorry for the wavy. So this is at negative pi over 2. You also get -1 at negative pi over 2. So you can see how that could be a solution that's correct. There we go. Okay, so the answers are negative pi over 2, negative 90 degrees, pi over 6, which is 30 degrees, and 5 pi over 6, which is 150 degrees. Those are within the range that we were given, and that's why we're accepting them as correct solutions. That's it for this question. We can end this video here. I look forward to seeing you in the next video. Feel free to comment below and tell me what topics you'd like us to tackle and which level of IB you're doing. I'm more than excited to do any type of IB and work on any type of graphing calculator. If you have specific graphing calculators that you want us to review how they work, we can do that. So I look forward to seeing your comments down below. Subscribe and continue learning with me.